Okay, we have here another expression. Okay, we have the negation of P conditional Q that is linked by a conjunction with the negation of Q conditional the negation of P. Okay. Now this is a tricky one. This is really important because this is kind of one that we should have more or we should pay more attention. Okay, be really aware of this one. Okay. Now we are going to make, or we are going to yes, we are going to do the same steps as we did in the previous example. Remember that the first step is to write the variables in the order that appears in the expression to the left. So we have this expression and we have only two variables, P and Q. Both are repeated, but that doesn't matter. So the first one that appears in the expression is P, okay? And the second one that appears in the expression is Q, okay? So we write the variables at the left or to the left of the expression, okay? The next step is to determine the number of lines that we have in this, or that we are going to have in this truth table. Remember that the way to determine how many lines we are going to have is with this formula 2 to the power n, where n is the number of variables. In this case we have two variables, P and Q. That's the reason we have 2 square. So finally we will have 4 lines. Okay, so we write them. We write the 4 lines. So 1, 2, 3, 4, and we can write already the columns of the variable. Remember that this is the variable combination zone. So in the variable combination zone, we will have we need to write. Remember that each variable can be true or false. Okay, we have 2 possibilities for each value and for each case. So remember that in the variable combination zone, we start always with the first variable of the right and we go to the left. In this case, we are going to start with Q and we are going to alternate true and false until we finish. Okay, and then in the following column to the left, we are going to alternate 2 times true and 2 times false. As simple as that. Okay. Now, the following step is the one that is like the most important one, that is like the determination of the grade of dominance of the expression, okay? Now, this is really important, and that's the reason I chose this example, because it's not easy to read, okay? Because we need to be really aware about the use of the punctuation and the use of the hierarchy of the logical connectives. Now, if I ask you, what is the most important logical connective here, what would you say? Okay, I don't expect an answer, I'm really sorry. As you can see, the most important logical connective here is the negation. And that's the example, or the thing that I told you the last time. If the punctuation, the use of the punctuation, the brackets or the parentheses or braces changes the way we read the expression. Normally, if we don't have a punctuation marks, the negation will be like the least dominant logical connective. But in this case, even though the negation is the least dominant logical connective, because of the arrangement or how the expression is built, the negation is going to be the most important logical connective. Why? Because this expression is affecting to all the brackets, or to all that is contained into the brackets. Okay, as you can see. So since this is the last thing that is affecting the whole expression contained in this bracket, is going to be the most important or the most dominant logical connective. Okay, so we are going to write 1 here, 1, and we have our primary logical connective already. Now the problem is this part. What would be the second logical connective? if you think that is this conjunction that maybe you did, that is wrong, okay? And obviously it cannot be this conditional between P and Q, because this conditional is linked with this conjunction to this expression. Now, this is the point. We have an expression that is within this parenthesis P conditional Q, okay? And then we see that this is linked with the negation of Q, and then this negation of Q is linked to this negation of P with this conditional. In this part of the expression, we need to be really careful. The most important logical connective, or well, the secondary logical connective, because we have already the most important one here in the negation, is going to be this conditional. Because between this conditional and this conjunction, the most important, or the one that has more hierarchy in the grade of dominance of the logical connective, is the conditional, okay? So since the conditional is more important, or has more range in the scale of the logical connectives, this is going to be the number 2. Now imagine that, for example, hypothetically speaking, we add some parentheses here. If we add this parenthesis, this is not any longer the 2. Now the second one, or the number 2, is going to be this one. Can you see how the use of the punctuation mark, parentheses, bracket, braces plays a key role in here? So I'm going to not suppose again, and I'm going to say that this is the second one, okay? Now, this is the second one, and then we have the P conditional Q and the conjunction negation Q and negation P, okay? Now, we need to analyze this. This conjunction is linking this parenthesis with this negation of Q. It's like, imagine that we rewrite this expression. We could imagine, for example, that we put some brackets here, yes? And instead of these brackets, now those are braces. Imagine that hypothetically we made these changes. As you can see, that is the very same expression. I'm not going to complicate things, but since this is the second logical connective, now we have the conjunction. In order to solve this conjunction, I need to solve first this conditional between P and Q and this negation of Q. So we can say, so we can say that the number 3 is going to be this this conjunction, okay? Now, as I said, this conjunction needs the solution first of this conditional between P and Q and this negation of Q. So let's say that, for example, 4 is going to be the conditional between P and Q, and finally, let's say that, 5 is going to be the negation of Q and the negation of P, okay? We are solve first of all, we are going to solve the number 5, that is the negation of Q and the negation of P, Q and P, yes. Then 4, and then now we can solve 3. We are going to solve 3 with 4 and 5. Wait a moment, okay? So now, since we already stated or established the level of dominance of the expression that, as I already told you, that is like the most important part of the truth table, we can now separate these in columns. And how can we know that? Well, with the given dominance of the logical connectives. This dominance is going to tell us how to separate this part of the chart in columns. For example, do we need a column here to separate this number 1, that is the primary logical connective? Yes. So we are going to separate the negation in 1. Now, what is going to happen here? We have 4 as this expression, 5 with this expression, and 3 here. So we are going to put one column here and another column here. And this expression number 2, where we have the negation of Q, we know Q, but negation of Q is not the same as Q, and the negation of P is not the same as P, so we need another column here and another column here, okay? And now we have the columns of the logic, the truth table. Now, until this point, if we stated or established correctly the level of dominance of each logical connective, if we have done that correctly, we could say that the remaining part or the remaining step is just the application of the rules. Just that, and be careful and being careful with those applications, okay, or with this process. But the most important thing is this one, okay? So let's do the following steps. Now we can see that our primary logical connective is this negation, but we cannot solve this negation if we haven't solved yet what is inside these brackets, okay? Now then we said that the most important logical connective within these brackets is the conditional. As you can see, the dynamic or the way of reading is that trying to find what I call like the heart of the expression. If I want to solve this, I need to test previously this, and if I need to solve this conditional, I need to test or see what do I need in order to solve this. It's trying to go deeper and deeper and deeper to the expression, okay? So this conditional needs the solution of number 3, but I see that number 3 needs first the solution of 4 and the solution of 5, because this conjunction is linking 4 and 5, okay? It's always starting with the least dominant logical connectives. I need to solve, for example, the negation of Q and the conditional between P and Q in order to solve the number 3. So we can start, for example, with these ones, with the number 5, that are the least dominant logical connectives. The negation of Q is going to invert the values given of Q here. So we have true, we will have here false. Then false, this is true. True, this is false. False, this is true. Okay? We are going to invert, due to this negation, the values given of P. So we have true, this is false. We have true, this is false. This is false, this is true. This is false, this is true. Okay? Now, I cannot solve yet, because this is the most important logical connective here in the bracket, the conditional. I need to solve first the number 3. But the number 3 needs the solution of 5, that I already have it here, and the solution of 4. Can I solve immediately the conditional between P and Q? Yes, I can. Remember that the conditional says that the conditional is, or the rule of the conditional says that the conditional is always true, except when the antecedent, that is P, is true and the consequent is false. P is the antecedent and Q is the consequent, okay? So P is true and Q is true. So true and true is going to be true. Again, the conditional is always true except when the antecedent P is true and the consequent Q is false. So in this case, that is false. And false, this is going to be true. Okay? Now, once I already solved number 4 and number 5, I can now solve number 3. Number 3 is a conjunction. The conjunction that is going to take in consideration number 4 and number 5. So in this sense, remember the rule of the conjunction. The conjunction is always true, the conjunction is true when both of the components of the conjunction are true. The components is 4 or are 4 and 5. Okay? These both are the components of the conjunction. So true and false, this is going to be false. False and true, false. True and false, false. And finally, true and true, this is going to be true. Okay? And finally, my lovely students, for these brackets, I already solved 3. So I need the conditional in number 2. Remember that the conditional always states an antecedent and a consequent. So the antecedent, this is really important, and this is how we read the expression. The antecedent of this number 2 is going to be this number 3. This is the antecedent. And the consequent of this number 2 of this conditional is this number 5, consequent. As you can see, this logical connective number 2, or the secondary one, is linking number 3 with number 5. We already solved number 3 and we already solved number 5. Okay? So we are going to do the same process. Okay? In here we have this one as the antecedent, okay, and this one as the consequent. Okay? So we take this column as the antecedent and this column as the consequent. And remember again, the rule of the conditional is it is always true except when the antecedent is true and the consequent is false. So false and false, this is going to be true. False and false, this is going to be true. False and false, this is going to be true. And finally, true and true, this is going to be true. There wasn't a case in which the antecedent was true and the consequent was false. We didn't have any case of that. Now, finally, now we can make or solve the negation. Once we already solved this, we are going to compare this negation to the most or to the secondary logical connective that is inside the brackets. So the negation is going to, sorry for the redundancy, to negate is going to, it's going to deny, sorry, this number 2, this column, okay? Because this was like the secondary logical connective. Remember that we are going by grades, okay? For the least dominant connective to the most dominant connectives. So, true, this is going to be false. True, false, true, false, true, false. So our last column is the negation that is false, 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 and we say that this is known as a contradiction. Contradiction. And we already solved the truth table. So we have here another exercise. That is, as you can see, at first sight kind of more complicated because we have R, S, and P. We have 3 variables, okay? So we will need 8 lines. And I'm going to solve it, okay? We are going to solve it. Okay, what? So we have, the first step is, remember always, to write to the left of the expression the variable that in the order that they appear in the expression. So we have 1 variable with R, 2 with S, and 3 with P, okay? And we are going to write these 3 variables to the left of the expression. So the first one that appears in the expression is R, and we are going to write here R. Then the second one that appears in the expression is S, and finally the one that appears finally in the expression is P. Okay? So we already have our variables to the left, and now the following or the next step is to determine the lines that our truth table will have. As I already said, since we have 3 variables, 2 to the third power is 8, but we apply the formula, just to remember, 2 to the n power, being n the number of variables that we have, that in this case we have 1, 2, 3 variables. This is equal to 2 to the third power, and that is 8. Okay? So we will have 8 lines. 1, 2, 3, 4, 5, 6, 7, So once we have the 8 lines determined by the formula that we already know, well, we can complete the variable combination zone or area that we know. We have this left part, and remember that for the variable combination area we have 3 variables, R, S, P. And remember that, imagine that we are not seeing this part of the truth table. Imagine that we are not now only paying attention to this part, okay? When we determine the values of the variable combination area, remember that a variable can be only true or false, only that, okay? So in that sense, P can be true or false, S can be true or false, and R can be true or false, blah, blah, you know? But in the variable combination area, we are going to start with the first column of the right, and we are going to move forward to the left, okay? We are starting with this column of the right, and we move forward to the variables of the left. So in the first column, we are going to start alternating true and false values until we finish. So this is true, false, true, false, true, false, true, false. In the following column to the left, we have the variable S. In this one, we are going to alternate. Remember the logic, or remember the dynamic of this variable combination zone. We're going to alternate 2 times true and 2 times false, 2 times true and 2 times false until we finish, and so on and so on. So we have true, true, false, false, true, true, false, false. And since we have now a third variable, we are going, if we have like 1 time, like 2 times, we are going to have 4 times. So we will have true, 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 and the remaining ones I'm going to be false, 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 and false. Okay? Now, if we already done that, we are going to do the most important part and the most difficult one, that is determining the level of dominance of the logical connectives. Now, remember, the one tip that I can give you, and that is really important, my lovely students, is please be really aware or try to seek first the most important logical connective, or the primary one. Because if you search, if you find which one is the primary logical connective, you can see like the behavior of this expression, you know, because you could say, okay, this is the primary logical connective, and then this links or connects this expression with this expression, or in order to solve this, I need to solve first this or that, you know. So the first tip, or well, I don't know what number is this tip, you know, but one of the tips that I can give you is to search always first the logical, the primary logical connective, okay? So in this case, as you can see, this conditional is linking this whole expression, this negation of this inclusive disjunction, with this whole expression, this negation of this whole expression that is conformed by the negation of R, the conjunction, and the negation of P. So this is linking both expressions, or both negations actually, yes? And in that sense, for this conditional, this is going to be the antecedent, and this is going to be the consequent, okay? Now, therefore, our first, or our primary logical connective, our most dominant logical connective, is going to be the conditional, okay? Now, this is really important. For this expression, which one is the most important logical connective for this expression? The inclusive disjunction or the negation? The negation, because the negation needs the solution of the inclusive disjunction. The same happens actually in this one. We cannot solve this negation if we couldn't, or if we haven't solved yet the conjunction between the negation of R and the negation of P. See? Yes? Yes? So, the second degree, the second level of the logical connectives are going to be both negations, okay? I'm going to write that by the number 2. Okay, because at the end, for this conditional, you are going to compare this one with this one. This one is going to be your antecedent, and this one is going to be your consequent, actually. Okay. Now, if we, for example, we already analyzed that we have in the second degree both negations. Now, obviously, in the third place or in the third degree, is going to be, for example, in the case of the left of the conditional, is going to be the inclusive disjunction, and in this case, one question: can we solve this conjunction without solving previously this negation of R and this negation of P? No, we cannot do that. So this is going to be 3 as well. And finally, the fourth degree, or the least dominant connectives, the weakest dominant connectives are going to be these both negations, okay? So the dynamic is this one. In order to solve 3, we have to solve the negation of R and the negation of P. 3 needs the solution of both 4s, okay? For the solution of these 3, we can solve it actually immediately because we have R and S, okay? And we are going to solve this negation invert if we invert these values, but we need to solve further this inclusive disjunction. The same happens here. Once we solve these 3, we are going to solve number 2, and now once we have solved both this number 2 and this number 2, we can solve number 1. Okay, so now we can separate these in columns. So, for example, I know that the logical or the principal logical connective is going to be this, so I need a column there. I need a column here because the negation, the 3. I need a column here, the number 2, and now here I need a column. Okay, I will write a column because the values of the negation of R and the values of the negation of P are not given immediately. I need to invert these values from these columns. So I'm going to separate this in this, okay, and those are our columns. Okay, now once we separated the logical connectives considering the level of dominance, we can now only apply it as well. Again, the most important part of a truth table, in my opinion, is this process, you know. Later you need only to apply the rules and just be careful with that, but in the part that we need to think more and more and more are this part, okay? Now, we are going to start solving, for example, the number 4, okay? So we have negation of R and negation of P. I'm going to invert the values of R and I'm going to invert the values of P. I have true, false, so here I will have false, true, false, true, false, true, false, true. In the negation of R, I'm going to invert these values of R. So we have false, 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 true, 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 true. Okay, that was number 4. Okay. Number 3, once I solved these number 4s, I can now solve the conjunction of number 3, considering the negation of R and the negation of P. Now, the conjunction, remember, is always true, or is true when both of its components are true. So, false, false is going to be false. False and true, false. False and false, false. False and true, false. True and false, false. True and true, true. True and false, false. True and true, true. So only in these cases, because both components of the conjunction are true, the conjunction itself is going to be true. Okay? So in the inclusive disjunction, it's actually kind of the same rule, but in vice versa, you know, because the inclusive disjunction is false when both of its components are false. Okay? Otherwise, the inclusive disjunction is always true. So in this case, we have already given the values of R and S. We have true, true, blah, blah. So we need to check or compare these two columns in order to solve this inclusive disjunction. Sorry, so we have R and S. So true and true, this is going to be true. True and true, sorry, I put I wrote a false. True, true and true, true, true and false, true, true and false, true, false and true, true, false and true, true, false and false, false, and false and false, false. Okay? Now, we already solved number 3. Now we can solve number 2 and number 2, and the number 2 is going to change this column, number 2 is going to change this column, and this number 2 is going to change this column. So we invert these values. We have true, false, there is a false, 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 true, true. Okay? Yes. And this number 2 is going to invert the number 3. So we have true, 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 false, true, false. Okay? And finally, in our truth table, we can now solve the primary logical connective considering these number 2s, okay? This negation and this negation. This negation is going to be the antecedent, negation. This negation is going to be the antecedent, and this negation is going to be the consequent. The consequent, okay? So remember that the rule of the conditional is always true except when the antecedent is true and the consequent is false, okay? So we are going to compare the blue columns, okay? If this one is true and this is false, the conditional is going to be false. Otherwise, always the conditional is always true. So false and false and false and false and all of these ones that are false immediately are going to be true. I don't need even to compare with this because the only possibility that the conditional is false is when we have true here in the antecedent. So false and true, true. False and true, true. False and true, true. False and true, true. Me parece una canción. False and true, true. False and false is still true. Now, true and true is still true. And true and false here, in the only case in which the antecedent is true and the consequent is false is actually in the last one. So this is going to be false. And the final result is this one. As you can see, we have all the values true except by the last one that is false. Even if you have only one value as false, that is contingent, okay? The final result is that this truth table is contingent. Imagine that you have all the values as false and one as true is the same. If you have a mix up there, it's going to be between true and false. That is going to be always a contingent truth table. Okay, and maybe you can see that. Well, okay.